Welcome, and thank you for joining us for this conversation on exploring the future of carbon capture and utilization. My name is Volker. I'm the director of the Global CO2 Initiative at the University of Michigan. I'm a professor in mechanical engineering and faculty director in our Center for Entrepreneurship. I'm joined today by Jennifer Haverkamp, the Graham Family Director of the Graham Sustainability Institute, professor from practice at Michigan Law School, and professor of practice at the Ford School of Public Policy. I'm also joined by Jerry Davis, the Gilbert and Ruth Whitaker Professor of Business Administration and Sociology at our Ross School of Business. He's also faculty director of the Business+Impact program at Ross. So today, we are excited to share with us a conversation on how carbon-based products are really essential to our livelihood, to our existence. But of course, as we all know, they are also one of the key reasons for climate change and the negative effects that we observe every day, and increasingly so. Namely, fossil fuels and derived chemicals are amongst the problem. So, in one sense, we need to eliminate fossil fuels and fossil carbon as much as possible and as soon as possible. But then again, how do we reconcile these two conflicting requirements? We can't live without carbon products, and we need to eliminate them. So alternative sources of carbon become a real necessity. Of course, we can turn to nature and harvest plants, biomass, as a key resource. We can recycle as much carbon-containing material as possible. But it has long been quantified that neither of those sources will be adequate to cover even existing needs, needless to say, the growing demand in developing nations. So today we want to explore with you the opportunity that carbon capture and utilization provides. In that context, we need to be specific in saying that utilization here means chemical conversion into products. So we are not looking at processing fluids for materials cutting and oil recovery, for example, in that context. So it is also clear that while of enormous opportunity, CCU, carbon capture and utilization, is only one of many activities that we need to engage in. We need to deploy them fast. We need to deploy them at large scales. And one of the key questions then is, how do we do this responsibly and fast? How do we avoid mistakes? And in that sense, I'm curious what you, Jennifer, think about CCU in a broader context of sustainability and how we go forward.
Thanks, Volker. And hello, everyone. Pleased to be with you this afternoon. I think one of the part of the context we need to have here is that the Intergovernmental Panel on Climate Change, the IPCC, has projected that if we are going to stay below 1.5 degrees of warming, which is what's needed to avoid the worst, the dangerous effects of climate change, that by 2050, we probably need to be removing around 5 gigatons per year of carbon from the atmosphere. And so part of this conversation is what contribution can carbon capture and utilization make to that solution? There are other things that need to be done. I guess the other thing I would just say is today we are focused on carbon capture and utilization. This is not a conversation about carbon capture and sequestration, which is also no doubt part of the solutions that will be needed going forward.
So looking at it from a business point of view, Jerry, what makes you curious about this field and the opportunities that hopefully lie within?
Yeah, well, thank you for having me on this panel. Delighted to be with you all. I've been really fascinated by your work, Volker, and the National Academy's work on all the different kinds of industries that could be transformed by carbon capture and utilization. It might be helpful to hear some of these products from you, but the opportunities for creating new kinds of businesses around the world at small scale, at large scale is really exciting, like making it a business opportunity seems much more interesting than here are the industries that we need to euthanize. We probably do need to euthanize some industries, but there are others that can grow in their place, sometimes relying on the same sets of capabilities. So in some sense, CCU seems to create this opportunity for a transition that I don't think has gotten maybe the attention that it deserves. But you might want to share with us some of the ideas about the products or industries where CCU has been possible.
Yeah, indeed. And I believe one of the complexities of this CCU industry that has to be built is that it actually is so many things. And it serves fundamentally two purposes if we want. The conversion of carbon dioxide into products can result in products that have a very long lifetime. For example, concrete or gravel, some polymers or carbon fibers, very, very long lifetime, which effectively removes the CO2, just like you would sequester it underground. But now you also have a product to sell and use. And the other key function of CCU is to replace other forms of carbon feedstocks, namely fossil feedstocks, with CO2 and convert, let me call them consumer products, starting with soap, with chemicals that are needed for all kinds of purposes, including making plastics. And needless to say, fuel. And there in particular, I think we may want to look at what is the best use of these products and these technologies, because this is not just about replacing one technology with another that can be cleaner, but it also is to create new opportunities that might not have been a reality in the past. A key example I think I always draw from is the great horse manure crisis from 1894. When cities around the world started to drown in horse manure because there were too many horses in cities. The solution was not to find a clever way to pick up the manure and do something useful with it. The solution was the automobile. Right? And it took on like a brush fire. Within 20 years, pretty much most horses had been replaced by automobiles, assisted by creativity, ingenuity in manufacturing, just around the corner from here in Dearborn, the Ford factories. So I think something similar is happening with how we deal with climate change.
I would say I agree with much of what you said, but I would also say that automobiles took off not only because they didn't produce manure, right? The transition was fueled by they provided amenities that horse and buggy didn't. They could go faster. They, that was probably the biggest thing. But similarly, I think as we try to replace in the marketplace certain products with those that are produced from carbon utilization, those products need to still meet a need or satisfy a demand. Maybe they're substitutable, but if they're more expensive, then you've got to have some other part of the formula to get them to take off at the scale that we need. And I mean, I think in one area, you mentioned fuels. I think that is especially an area where government incentives and policy incentives are going to be necessary to move the market along.
I fully agree, and I think you put the finger in the open wound, right? Because in a sense, you in the business world have the challenge to replace something we already have and enjoy, use at often reasonable prices with something that is more or less, if not exactly the same thing, but will cost more.
Yeah.
So the value proposition formulation is a challenge. How do we think about this? Is policy the right approach in that sense?
Yeah. So in some sense, if you think, what does it take to create the businesses that will make these products at a price people can afford? Sometimes it's policy and sometimes it's innovations elsewhere in the ecosystem of business. I'm going to tell a bit of a shaggy dog story because you raised the example of the auto industry and where it came from. So here at the campus of the University of Michigan, many of the buildings were designed by Albert Kahn. He's a famous architect. He's done all styles of architecture. is really the father of the 20th century factory. So if you see Henry Ford's second factory in Detroit, the Piquette plant, it's made of wood and masonry and old school glass. To make factories big enough to do mass production, to make cars accessible to a broad public, you needed to have reinforced concrete. And a good design for reinforced concrete had sort of eluded the world until about 1904. Turns out that Albert Kahn's brother Julius got the patent for the best design for reinforced concrete. Now we have this material that enabled Albert Kahn to design factories that had acres of floors, floor after floor, ramps running from one to the next. But we wouldn't have mass production of cars if we didn't have these innovations in architecture. So it wasn't just the innovation in the car, it was the architecture that enabled the car factories to be built and to do so, and to keep driving down costs. And so I'm wondering, like, what might those elements be? Is there an analog to sort of the reinforced concrete, machine rolled glass, structural steel that made factories possible? Are there analogs to that, other developments in the ecosystem that we might think of as enabling CCU to take off? I know it's a little bit of a psychedelic question, but.
Well, I think it's an interesting and important one to consider, because we often ask ourselves, what is the right scale for these production facilities? On one hand, we projected that we can use gigatons of CO2 a year to make products. How well this would work is not only a function of what the cost is, but also logistics. If we really need to capture billions of tons of CO2 a year, where do we do this? How do we get the production facilities nearby or capture near production facilities is a big question. We cannot really centralize concrete production because you cannot ship it for cost reasons, because it's heavy, and also it would cure before you arrive. So a lot of those kind of dilemmas need to be solved. What is the technological and economic sweet spot for such a combination of capturing and converting the CO2 has to be figured out.
And I think you've put your finger on one of the other, there's many, but one of the other conundrums around this, which is that at least at current technologies, direct air capture is a very expensive way to try to take carbon dioxide out of the atmosphere. Keep in mind that it's right now at about 420 parts per million in the atmosphere. So that's a lot of air that you have to go through to get that carbon dioxide. So the more efficient way to collect it for these kinds of uses is at point sources, but you don't want to develop an industry that is reliant on continuing to have point sources where fossil fuels are being burned. So what are the other kinds of point sources that we could be thinking about?
Yeah, and I think in addition to what you just highlighted, an absolutely essential point, you don't want to invest in something that is known to disappear. There's also the issue that even if we capture from a fossil point source, we would then convert this material into, let's say, a fuel, an aviation fuel, burn it, and now we have added more fossil carbon to the atmosphere. So if we do this, we have to turn this CO2 into durable, long-lived products, such as concrete. That's a big thing. On the other hand, yes, we can think about other point sources. I think the big one, literally around our corner, is the biorefineries in the Midwest that produce bioethanol that's to a large extent used as a blend material for gasoline. And when you ferment biomass, sugars in particular, to produce ethanol, there's always carbon dioxide as a byproduct. So this is a literally golden opportunity because it's of very high purity and it's considered a waste, usually just let go. So harvesting that CO2 and using it to convert to aviation fuel, we just completed a study that examined this, is a really fantastic opportunity to help launch this business.
Mm.
Because now we have the lowest possible, highest purity CO2 and can use that to start your production, learn and scale.
Mm.
There is, on the other hand, of course, also a competition for that CO2 because emitters get paid, or those collecting it get paid to store it underground. There's a tax rebate for that.
Mhm.
So the conversion to fuels needs to be more lucrative, and I think that is one of the challenges to make sure that this is done fast enough to produce at a cost where it's actually viable.
I also think one of the areas that I know that your institute has put a lot of energy into is the need for life cycle analyses of these products. And in the example you gave, I think that would also be really important. I think we've all heard of the controversy around corn-based ethanol. And the idea that by the time you consider all the energy inputs of producing that corn, it's not at all clear that it has a positive impact on climate change. It may generate more emissions along the way, and it also shifts a lot of production of soybeans to tropical forests, where then you've got those taken down and you lose the carbon sink benefit there. So I guess I would say let's keep looking. Back to Jerry's question, let's keep looking for good pure sources of carbon dioxide, because I think at least some people would have concerns about that as becoming part of the economic argument to keep producing corn-based ethanol. Though there, at least in the near term, there's plenty of demand for it, and there will be increasing demand from the aviation industry for that as a sustainable aviation biofuel.
Indeed, but there's also decreasing demand from ground transportation
As
we
we get
electrify.
electric vehicles.
So I think that is probably one of the reasons why there is so much focus on SAF production from bioethanol. So keep that industry going. But I think fundamentally, one could certainly start looking at alternative crops. If we compare corn ethanol to beet-based ethanol, there's a significant difference in the life cycle emissions. I think what at present, holistically, saves the day for CO2-based aviation fuel from this point source is that in the life cycle assessment of bioethanol, the emitted CO2 is not burdened anymore. So at least the aviation fuel is sort of, if you want, clean in that context. But globally, for the planet, of course, yes, that remains an issue. And of course, the soil depletion and salination of the soil remain big issues. But I think point source CO2 is most certainly for these circularly used products always a good opportunity for any sort of biomass conversion. We can also look at waste incineration as sort of a compromise, but there's a lot of waste biomass that currently just
Turns into methane.
Just slowly in an uncontrolled manner turns into methane. So if we use this in plants that right here in Western Michigan, there's a large coal-fired power plant that is being retired and retrofit to burn biomass. So there, if we extract the energy from that combustion process and capture the CO2, we once again have a source that creative businesses can pick up on and turn to profits.
I would love to pick up on Jerry's example of reinforced concrete. Volker, can you say more about the potential for carbon capture and utilization in the realm of building materials?
And if we could address this like I'm 12 years old and haven't taken classes in chemistry in a very long time. So maybe if you could break down, like, what does it look like? What does carbon capture look like in the concrete industry? So make it concrete. So.
I would try my best, but
I'll just reinforce that.
To give you peace of mind, my last chemistry class is decades ago. So let's see what I've retained. But
Or sequestered.
or sequestered, yeah, in the deep bowels of my brain. The key opportunity for construction or building materials in the context of CO2 based products is their lifetime. If we take that CO2, and just to be clear, that CO2 is converted into rock-like materials. It's not that it's stored as a gas. So even if the concrete is falling apart or torn down, the gas will not escape because it's no longer a gas. And then the big opportunity is the amount of construction materials we use. Worldwide, we make more than 30 billion tons of concrete every year. By 2050, we projected that the world will need 120 billion tons of gravel every year. These are amounts that are just almost too large to comprehend. Right? So let's imagine that even if we make a fraction of these materials with the use of CO2, that could be gigatons of CO2 that can be used. And the important element here is that CO2 remains removed. So it really counts as a negative emission in that context. Once again, we still are left with where do we take the CO2 from? Right? If we take it, let's say, from a biorefinery, that CO2 is now removed and we have less CO2 in the environment than before because the plants have taken it from the air in the first place. If we take it from a power plant, say a coal-fired power plant or natural gas-fired power plant, we would, in principle, have the opportunity to arrive at a carbon neutral product. Because instead of letting the CO2 escape into the atmosphere, we lock it up in this product. That's overall a good thing and a practical thing because it lowers the cost of deployment. But we also have to be honest enough and say, this is not 100% efficient. So if we install these capture facilities at emitters, we capture maybe 90, 95%, maybe even a bit more of the CO2, but not all. So 5% of a lot is still a lot. So we have to think about how we handle that difference. But I think it certainly is a large-scale opportunity. And once again, an opportunity that leads to potential businesses in many different locations. There are literally millions of concrete producers around the world. If all of them could do a little bit, that would be huge.
And could you visualize, we have spoken about ways that you could imagine using the resources of fossil fuel companies, like they're really good at moving liquids around. Could you transition those talents or those competencies into, say, getting reasonably pure CO2 into the hands of those millions of concrete producers, or is that too psychedelic?
Well, I think it's not only not psychedelic, it's essential. It's essential to success. We have to help transition these industries for many reasons, starting with the jobs. There are hundreds of thousands of people who work in this industry, and at the end of the day, you cannot leave them without income.
Yeah.
So that's a huge societal responsibility to begin with. More so, though, the skills and the expertise in these companies are really very similar to what we need to capture CO2, transport it, convert it to products. Large amount of chemical conversion, reactors, refineries, all of that is needed for sustainable aviation fuel production as well. So here is a need and an opportunity and something that we really need to work on very quickly to ensure that this expertise is not lost. And yes, some of it will be different in terms of the skills that people need. But I think it's an exciting opportunity. If your job tomorrow actually can help save the planet. And case in point, in my previous academic life, where I worked a lot with the automotive industry on internal combustion engine research, It was very clear at some point the last decade that the local companies would very quickly ramp down their investigation in combustion engines. And literally overnight, many of my collaborators in Detroit became specialists for electric vehicles, just by definition of the company. So instead of researching and developing combustion engines, they now work on electric motors and so forth. So I think that is a process that is not unknown in the industry. But the scale and the time scale that we need to make this happen, I think, is critical.
Yeah.
Because usually industries, and I'm sure you can share many stories about it, industries slowly develop. We had hundreds of automobile companies in the early 20th century. Now we have a handful. We don't have the luxury of letting that economic system play itself out. We need to make decisions now. What are the best bets? And then help deploy those so that we have the best impact on climate.
Is that really the way that you would do it, is to try to pick the winners instead of create hundreds of startups and see which ones succeed?
I would try to eliminate the losers.
That's fair.
Great question. No, because how would anyone know what is a seemingly good idea, but there are some technology barriers that maybe in a few years' time are not barriers anymore.
Yeah.
So we cannot ever be that arrogant to do that. But there are certainly developments where early life cycle assessments show us that unless significant changes are made to particular subsets of that technology, let's say the materials that are used, the manufacturing process, it will never be as good as it can be, and therefore either needs to be changed or stopped.
I really appreciated you flagging the urgency, and would love, Jerry, especially to hear your thoughts on what are the levers and incentives that would move this industry along at the pace we need it to. And I'm happy to talk about some of the government policies and levers that I have in mind, but I'm curious on the business side, what have you seen work, or what do you think is needed here?
Yeah, so Rosa Luxemburg wrote this lovely book about 120 years ago called Reform or Revolution. And my own feeling is, why not both? When it comes to business, so reform is, how do we take the existing big companies that we have, use those talents and competencies that they have, and sort of point them in a different direction. So maybe rather than euthanizing fossil fuels, we can figure out what are they good at and how do we help them find a path forward away from fossil fuels. And you shared some thoughts about that. The revolution is like, how do we create new kinds of businesses, small enterprises that can rapidly grow and explore things that aren't likely to be as interesting for sort of the bigger enterprises. You can actually see this in your former industry of cars. So there used to be hundreds of auto companies in the US, then there were 3. But the last time I checked, there are 14 listed car companies on American stock markets. And some of them you've heard of, like Rivian and Tesla and General Motors and Ford. Maybe others, Fisker, Muller Automotive, Phoenix, you might not have heard of. But 14, when I dug into it, many of them had fewer than 1,000 employees. They were enabled by the EV revolution. That if you're going to have a really different kind of car that's much simpler to assemble, you might have a third-party vendor that does the assembly of your cars, and you focus just on designing and marketing those things. So Fisker, the late lamented, they recently went into bankruptcy, but their model was to be like Nike. We're going to do design and marketing, but we're going to have initially a Canadian vendor that had an Austrian plant, Magnet International, to actually do the assembly of the cars. Like, that's fascinating. I think of car companies having the Rouge plant with 100,000 people making the steel and the glass and the concrete on site, but they had a different model. In some sense, you can sort of if you have the right firing gun, you can have the big companies adapting, like the big three automakers do, but also unleash smaller companies to try things out. And I think the levers at work are going to depend on which one of those you're thinking about. But it is an all hands on deck kind of situation. We need both. We need big players and we need scrappy startups at the same time. And I think the levers at work may look a little bit different for both of them. Government policy can help a lot with both. It's just different flavors of policy.
So one example of government policy that I'm familiar with is at the international level. And an area that has high demand for fuel is both shipping and aviation, which we've mentioned before. And there are some companies, I'm thinking of Maersk, the shipping company in particular, that is making a very big bet on new kinds of fuel. And they have, I think, they're building 25 ships that will operate on e-methanol, which, as I understand it, but back to your chemistry, I think e-methanol is hydrogen produced from renewable energy combined with carbon dioxide to make these fuels. So that's that's a product that's from carbon capture and utilization. And they've got 25 ships, and people think that the industry is on track to have 200 by 2028. And so that's going to create market demand. And I think that's driven not only by Maersk has been, I think, an environmentally responsible company for a long time, but it's also that the International Maritime Organization a year ago, July, set a global target for shipping of carbon neutral by 2050. And they have interim steps along the way that the industry is supposed to meet. And so that's a strong signal of government expectation in that area. You also, in aviation, the International Civil Aviation Organization has also stepped up to set targets and obligations with respect to decarbonizing aviation, which is a really hard sector to decarbonize. And there's a program called CORSIA, and I won't bore you with what it stands for, but CORSIA has been a voluntary program that in 2027 becomes mandatory, and it requires governments to require their airlines to reduce the emissions from their international flights to 2019 levels. And if they can't, they purchase offsets that are, officially blessed by the organization as being high quality offsets. But it's created a huge demand for sustainable aviation biofuel and sustainable aviation fuel. And I think similarly, that will be not only for the biofuels, but also, whatever the jet fuel equivalent of e-methanol is. So again, those are international levers that I think will help move this industry along.
I might ask a question about Maersk. Why is it a Danish company that is in the vanguard here? Are there any patterns about which places in the world are sort of fastest to adapt or to innovate in these realms? I mean, just looking at the rate that China is installing solar, are there particular kind of policy climates that are especially conducive to innovation like that or large uptake?
What a great question. I would say the reasons can vary. Like the structure of China's government allows them to create incentives and make things happen quickly, where a democracy, the bottom up might be much slower. But Denmark, I think that it's had a national culture that's been supportive of environmental action for a long time. Leader in wind power, and they have strong greenhouse gas reduction targets that also extend to the agricultural sector, which most of us don't do. So I can't put my finger on why somewhere like Denmark is a leader, but and whether Maersk would be a leader if it were headquartered in Spain, I don't know. It's a very good question.
So policy and elections matter.
Oh yes,
Indeed, right? I mean, not there's no single one mechanism to make these things work.
Mhm.
All that connection. At some point, I think, Jennifer, you mentioned that competition, that increasing competition for currently bio-based aviation fuel.
Mhm.
I mean, at some point, that competition is already visible in the demand for renewable electricity. Who gets to use it? Where does it make sense right now?
Mhm.
And how do we think about potential allocation? So ultimately, I think it becomes, again, a question of markets and how much am I willing to pay so I can meet my carbon neutrality commitment,
Mhm.
for example.
Mhm. Mhm.
I think we will not necessarily see a ban on traditional products, but certainly a consumer-driven interest in seeing replacements.
I mean, we've talked in the past about the circular economy, and I think we're seeing a bit of a separation of countries and trade, and the renewed popularity of tariffs for some reason. And so these policies sort of require you to be more nationally self-reliant for addressing problems. So in some sense, might this militate in favor of more locavore solutions to these kinds of issues? I don't know.
Well, I think from an environmental point of view, at first glance, it certainly seems plausible that whatever you do locally and doesn't have to be shipped around is a win, because you don't need energy to move pieces back and forth. How much that is really feasible is a different question. I think depending on the natural resources that you have, or even financial resources, not every country is sort of abundantly blessed with everything. That has a big impact. There are countries in Southeast Asia, in particular, that have long looked into sequestration of CO2, but they just don't have the geology to make that work. So, in that sense, even under that push to sort of be a little more localized and have, let's say, the carbon border adjustment mechanisms, that becomes impractical because somebody will have to buy offsets from somebody else. Somebody will go into the market of producing, let's say, a lot of concrete that might be at some point even carbon negative and therefore creates offsets. So having that play out, I think, is something that again takes long. Right? So hopefully next week in New York there will be plenty of conversations to move the needle, if ever so slowly. But again, it's September 19th of 2024. Not that long until 2050. So.
Do you want to say a little more for our audience about what the circular economy for carbon means, or how people are using that term in this area?
Yeah. It's thank you. It's again one of those many terms that mean so many different things to different people, and maybe starting with how we as humanity have operated over the last, especially 200 years at large scale, is essentially creating an extractive economy where we take raw materials from quarries, from mines, from wherever we find the materials we need. We make what we want to use it, and then throw them away. Economically driven, we have long lost the ability to repair devices. It's more convenient, cheaper to just get new ones. So what's missing here, though, is that on the one hand, you create a hole in the ground because you're taking ever more raw materials. And on the other hand, you're creating this big pile of garbage. So what we have to do is we have to bring those into an equilibrium so that there's a net zero flux of stuff taken out, stuff thrown away. Thinking about going back to nature by concept, there is no waste in nature. What one species waste is some other species food or building material. So the circular carbon economy, in a sense, is very similar. We take the carbon and reuse it over and over again. And that doesn't mean that what was the aviation fuel molecule today could not become soap tomorrow. It's just that the carbon that is used to turn to a product ends up as carbon dioxide or in our garbage can, is recollected and turned into another carbon product instead of taking new carbon out of the ground.
And I think what I would add to that is we today and looking ahead to solve the climate crisis, we can't just have circularity stasis right now because we had 150 years of imbalance of taking oil and coal and natural gas out of where it had been sequestered and we put it in the atmosphere. So we can't just circulate that and hope that we'll be okay. We have to, like, the whole topic of this conversation is how do we take stuff out and keep it out?
Yeah, indeed. It has to involve both. And I think that's the beauty of CCU. It can serve two essential functions: taking the CO2 out and leave it out, and creating a circular use opportunity to meet our carbon product needs. So it's really, from that point of view, a very good opportunity.
Is there, if you were a potential investor in this and wanted to get up to speed to be able to make smart choices, how hard is this going to be? Or where would you point someone that wanted to be able to sort of catalyze new businesses and new industries in this area? It has not yet become AI or crypto or whatever. So what might point those with money to invest in the right direction? Because it feels like we need that catalyst soon.
Indeed, and I mean, if we learn from history and sort of the evolution of AI, I mean, that has been decades in the making. It didn't come as a surprise, and boom, it was there. Somewhat similar, we are in a situation like that here now as well. Except I think the upfront investments in AI were probably less daunting than what we need to do here, even though it now turns out that huge amount of energy, of course, are needed to operate all the computers, storage facilities. So again, the competition for primary energy will become fierce to sort of continue using these new found tools and revolutionize, in your words, our existing production processes. And I think that's a real headache for us to deal with. I think we might want to soon start looking at some of the audience questions.
You're tired of answering Jerry and mine?
Oh, fire away.
No,
it's certainly. And I mean, the first question that I have here is really in that direction, that these carbon capture technologies are very high energy consumers, and therefore create challenges with large-scale deployments. Because clearly we cannot install a coal-fired power plant next to them to operate them. So how do we make that work? We need to build a new industry, and we need more of what already exists, and that is renewable energy. How do we think about this? We cannot wait until somebody builds more solar panels, right?
And we also can't put a whole lot of federal money into coal-fired power plants that would otherwise be retired soon. Right? You don't want to keep them limping along because of perhaps misguided effort to test the new technologies there.
Right. So clearly, while defossilization or decarbonization efforts have limitations without renewable energy, we cannot wait until somebody decides to build more solar panels hoping for demand. I believe this has to be sort of a give and take. More CCU deployments will demand more renewable electricity and so forth. Is that a good assumption?
Yeah. I wonder if you can make it concrete, so to speak. I want to go back to concrete because it seems, just given that the earth is swathed in roads now, and with my new Mustang Mach-E and its extremely heavy battery, it's going to be hard on the roads. So if we wanted to sort of ramp up this particular industry, and as you said, it's sort of localized, like how much more energy intensive is it to use carbon sequestering concrete than, say,
Clinker.
the regular kind? Is it?
Yeah, well, I think the key to success here is to be smart about the CO2 source. Because capturing CO2 from air, for example, is very expensive, energy intensive and money expensive. But when you look at the concrete production, one could think about using the CO2 emissions from a cement factory. So there are even in ways where you don't even need to separate it from the rest of the flue gas. You can stick it straight into concrete. And if you choose the mix of ingredients right, the concrete actually is stronger. So you will need to use less concrete to have the same strength, which for the environment is great. There's only one thing now. If you are a concrete producer and you make something that will cost at least a little bit more, and you can sell less, or people need less of it, that's bad for your business. So again, the struggle to what else can we do to this material to make it more attractive, so that people will pay for that premium, or the supplier, the producer can actually demand a higher premium.
And that might be another area for government policy incentives. You know, it could be that you set government procurement specs to, you know, give preference to that kind of concrete, for instance, or other products produced from CCU.
Oh, indeed. I mean, tried and tested method. Procurement requirements by governments go a long way. And governments, I mean, even here in the US, are the largest purchasers for essentially anything.
So in roads in particular, seems like got a perfectly made.
Yeah. And you know, I think roads are an interesting dilemma in a sense, because a lot of our roads are now paved with asphalt, which is sort of the last bit of stuff from crude oil that elsewhere cannot really be used. So if we stop using fossil fuels, we don't have asphalt anymore. So how do we build our roads? Concrete. But the concrete, as we produce it today, produces about 8% of global CO2 emissions.
That's right.
So there are exciting opportunities and wonderful technologies that actually take these CO2 emissions literally on the fly, stick them back into the kiln, and produce a type of cement that eventually can become close to carbon neutral. So creativity and waiting for technologies that at present are not really envisioned already is certainly something that we have to pay attention to. Not rule out the opportunities to point it out so well. Good. So here's a question that talks about regional or geographical strategies that perhaps are needed for successful CU expansion. An example given is, the order for this to be impactful, does CCU infrastructure need to be spread out across the globe, or could a few countries decide to be the hotspots? Do you have any thoughts on that?
I mean, given the history of the development of everything, every industry, I think it's inevitable that it will be a small number of countries that end up being the innovators and embracing it. Just another psychedelic example. In the US, we think Uber is the inevitable way to organize. This is not Uber, the one without the umlaut. So if you say smartphones with GPS enable riders and drivers to find each other for rides, in the US, we imagine there's exactly one way to implement that technology, and it looks like Uber. It's people using their personal vehicles to drive other people to the airport. But if you look around the world, this model looks completely different. I have a paper comparing Nigeria, India, Indonesia, China, Sweden, Germany, and the US, and how they've implemented this technology. And it just looks wildly different. The business models, who owns the cars, is this a gig job or profession? Everything looks different around the world. So I'd say based on that, there's thousands of examples like that. It's really going to vary by country. The way that new technologies get implemented are going to depend very critically on sort of the institutional structure of that country's economy.
And that's a good example from the services sector. When you think about manufacturing, it may well be that certain geographies will have reasons to develop faster than others, the industry or the products. You know, for something like, we've been talking a lot about concrete that's heavy and it's, you know, hard to ship around great distances, but other kinds of products, if the shipping costs aren't that great, the whole principle of comparative advantage in international trade is that certain places will be better suited to produce something at lower cost than others. And as long as we're not talking about products that have high national security implications, where each country should have their own industry, then I would think that you would probably be okay spreading it around, as long as it didn't raise justice and equity considerations around the ones that have the technology, you know, overcharging for it or restricting access to others. But a ton is a ton is a ton. So however you take a ton of carbon out of the atmosphere, wherever you take it out, it benefits all of us.
Indeed, and I think it will shake itself out. Who can do what best? The reasonable cost that needs to happen. There is a question about current prices for sourcing carbon dioxide for production in the US. Does it occur that bio-CCS and selling CDR credits, carbon dioxide removal credits, becomes a more attractive business model for biogenic CO2 emitters than selling CO2 for CCU companies? Indeed, a very plausible, and especially here in this country, acute risk, in that you need to look at who needs it more to produce CO2 and is perhaps willing to pay more than what companies get paid for sequestering CO2. There's tax rebates that have turned into direct payout programs. And therefore, of course, if you are a bio-based CO2 emitter, it's your choice to do with the CO2 whatever is working for you economically. So I think the conversation we had about the increasing demand for CO2-based materials, we talked specifically about the fuels, can attractively compete. So given that the production of that CO2 is essentially free for the biorefineries, it's now a question of who is willing to offer more. Because it will still be far lower cost than if we capture it from air.
In the example you gave, I suppose that another factor is how the voluntary carbon market evolves. If the trade-off is between selling the CO2 directly or getting the benefit of sequestering it and selling the credits, and it's quite fluid right now, as several international actors and even the current Biden administration have been looking for ways to set higher standards or criteria or, you know, procedures to figure out the carbon credits that represent real emission reductions from, you know, junk credits, and the price will probably go up.
True, and one question here asked is, what's the status of digital MRV in future of carbon credits measurement? So how do we think about this? I mean, who keeps track of who issues the credits and how valuable is it? Who owns it? Who used it? Will it expire? This is a daunting bookkeeping exercise that I think we don't really have an answer.
Well, it depends. I mean, some of the large organizations that set out methodologies and manage credits have registries. I mean, any of the reputable ones will assign a unique serial number to every ton sold
Mhm.
and retire that number after it's used as some
Mhm.
for that purpose. And it's usually a ton per year.
Mhm.
So it's a complicated world, but there's much more that can be done to tighten up.
And make it accessible, because yes, these exist, and I trust they do a really good job and are thorough with it. But if somebody wants to get into that business, how do they find out about this, and how do they participate? I think it's really hard.
Do you have time for a digression?
Absolutely, and I have one at the very bottom of this list.
Okay.
I follow yours first.
Well, this is just in the world of carbon crediting.
Mhm.
And it's a result of the Paris Agreement, where each country now establishes their own commitments, their own reduction expectations, and an awful lot of offset projects were in other countries, like tropical forest projects in developing countries. And one of the big questions for the people writing the rules for implementing the market mechanisms in the Paris Agreement were, how do you avoid double counting,
Mhm.
right? How do you not have the people who bought those credits claim it as a reduction in Germany, while Brazil might want to claim it as a reduction in their national total? And so they had to set up this whole system where basically now the developer of those projects in the developing country have to get a letter from the government saying, you can use those reductions, we won't.
Mhm.
So
Yeah, it's an interesting dilemma, right? And if every country does its own thing, that is really perplexing.
So
I have probably a closing question, especially near and dear to my heart as a professor and teacher here. How should this technology factor into university goals about climate action? Is this ready for prime time in that context?
well, one thing I would say is that universities can be and should be more than they already are living labs. And so where you have researchers working with students or with companies developing these technologies, and there are opportunities in the operations of the campus to safely test them, right? Then I think that will also help get things closer to marketability if you have some demonstration projects. Now it's a trade-off because universities also have to operate and educate students and not be shut down because the cement failed or whatever. so there are trade-offs, but that's one way that I would say that universities should be part of this process. And the universities could also consider in their own procurement standards, trying to incentivize greater production of these products.
Thank you.
I would say I can tell about the University of Michigan a little bit. The university is really good at pretty much everything, but distinctly among the places that I'm familiar with, we all kind of get along. People in very different schools and departments manage to find ways to collaborate. And I think that's what's going to be required to pull this off is you need discounted cash flow, and you need empathy, and you need engineering skills, and you need coders. And the ability to sort of gather them and deploy them, put them together as interdisciplinary teams to get things done. I think that's the secret sauce of a university that doesn't necessarily happen elsewhere in the real world.
And entities like our innovation partnerships, the part of the university that helps when research looks like it has marketability, helping the move to a startup or to find investors to spin off a profitable company.
Wonderful closing words. I think if I can summarize this, it's all hands on deck. And now. So thank you to our audience for dialing in today. We hope it was interesting to you, and I apologize if we didn't manage to get to all of your questions. If you are interested in replaying this, this webinar was recorded and will be made available in due time. Thank you so much and enjoy the rest of your day.
Bye.